also try out 3D modeling. And while I was looking through the project book, I had the idea that I could model one of, I was sure there was an RC car somewhere, I could model it off of a design from the game. And that's what this is. This is not the RC tank. It's completely different. It's sideways, it has wheels instead of treads, and it's got this massive case on it. Alright. And it is controlled with this wireless PS2 controller. And each wheel is controlled independently by each joystick. I also added, for some accuracy with the model and for fun, a set of 8 LEDs and a speaker on the inside. So when I press a button, it does a little chirp. The core of the RC car is, like many other projects, the Arduino. The Arduino is just a small, easily programmable computer, and it's hooked up to this wireless receiver here. It's been coded to interpret the signals from this and then decide whether to output signal to the wheels, to the lights, or to the speaker. I'd say my most challenging part was probably dealing with the wiring. It ended up at one point that the regulator for the Arduino is only supposed to run at 5 volts. That regulator that's supposed to take my 7.4 battery and run it at 5 volts broke. So my Arduino, for I don't know how long, but it should be broken, for the longest time it ran at 7.4 volts, which is really bad. So I had to solder on my own voltage regulator on the outside. Second to that was the modeling. I spent about 3 weeks using 2 grainy images of the thing I wanted, modeling it in SketchUp, which I had a little experience with, but was definitely not an expert with. Between the 3D printing and the modeling, this took about 3 weeks to finally get the case done. The only thing left was adding the lights and the speaker. So there's not that many modifications. There's only the lights, the speaker, and the entire thing not being the robot tank. I basically had to redesign the chassis to fit my design. I had to model a case on my own, and I had to write my own code because the Arduino did not support the code from the guide. The RC Robot Tank is really only similar at the core, using the PS2 controller, the receiver, the Arduino, and the motors. And other than that, this is completely custom. Then there's also the weirdly complicated LED and speaker system, which about doubled the amount of wiring in my little RC car. For some reason, the Arduinos just do not like LEDs and speakers. I really don't know. For 2 seemingly small features, that took a lot of time. So I was seriously considering an engineering path, but I didn't really know what I wanted to major in specifically. I just knew engineering. And going to Bluestamp, it really helped me understand from the electronics, coding, and robotics and 3D modeling, it really helped me understand a lot of the different branches of engineering. And I think it's really helped me refine my search.
You said the Arduino just didn't like your LEDs and your sound thing. What ended up being wrong with them?
Well, it was partially my fault because I soldered 8 LED wires to 1 wire, which is not a good idea, ever. But also, to power LEDs with an Arduino, you need to put a wire into one of the LED pins, or sorry, one of the Arduino pins, which basically just, that's how you put signal through something. You need to put one in a power pin, and you need to put one in a ground pin. So you need to have basically battery leads and a signal lead, and that is just a lot of wiring for a very simple circuit. Yep.
Did you end up having to use a breadboard, or did you just connect it all?
Yeah, actually, I only need this little voltage regulator here for the LEDs, but when my 5-volt regulator broke, I actually did have to use it's kind of like a breadboard, but you have to solder it. It's called a proto board. And then this here is how I actually power it, because I need an off-board 5-volt regulator since the onboard one is completely busted. Yeah.
So how did you actually figure out the onboard 5-volt?
We just tested the pins. So there's the ground pins and there's the 5-volt pin, so you can actually get 5 volts of power straight out of the Arduino. And using a digital multimeter, which just tells the voltage, we were able to find, hey, that's not 5 volts, that's 7.4, which is not supposed to happen. And the real problem with that is that the 5-volt regulator regulates the voltage of the Arduino and the 5-volt pin. So for one, it kept on breaking my controllers, which was annoying, and it probably should have broken the Arduino, but it didn't. I really don't know.
It's kind of two-parted. Number one, do you know how fast it goes? And if so, how would you modify it to make it go faster?
Okay, well, speed is actually kind of an issue with this because the original motors I used were not intended for the voltage I was running them at, but they were pretty fast. And when we replaced them with ones that were actually intended for the voltage that they're at, they're kind of slow and a little terrible. So to modify it, I just have to get better motors, I think. But currently, it really can't run that fast, especially on carpet. It doesn't like carpet. Oh, okay. Never mind. I have to figure out what's wrong. Demonstration for now. Yeah.
Did you short it?
Maybe.
There's a function that I feel is very much missing. Where's the flip button?
It is missing because it has a case on it. For reference, the motors used to be really powerful, so when this didn't have a case, if I were to go forwards really quickly and then go backwards, it would just flip right over. And now with the case, and with the weak motors, it can't really do that anymore. It can only hop up a little bit. Yeah.
So, I noticed you have Vex motor wheels on your robot, but I know that the actual gearbox that you use isn't Vex. So how did you get those two to play nice with each other?
Okay. This required a bit of help, but you can't really see it, but essentially the motor set in here uses hexagonal drive shafts that are really, really tiny, and these Vex motors use these big square ones. So I had to figure out a way to make them fit together. And basically what I ended up doing is using these things called shaft couplings. You can see them right here. It basically it gives a tight hold to a certain point. That's how I keep the motors in place. And then I 3D printed a part that basically is just two shaft couplings put together. So basically, I attach a shaft coupling to the hexagonal shafts and one to the square shafts, and you can kind of see it right here. Now they're joined together. And then that's a really unstable system, so I had to kind of jerry-rig it to be stable.
In the front of the case, what is that center panel?
Oh, most of this is aesthetic. I didn't know there was a projector. If I did, I probably would have shown an image, but this is mostly what the model looks like. I think this was a battery pack on the in-game model. Yeah.
Looks cool.
Thank you.